Hey folks, what's going on? Today we're going to be looking at making a really interesting system inside of TouchDesigner that can automatically crop the content that you're feeding it just by checking the value inside of the alpha pixels. So what we can see here before we dive into it is there's going to be a lot of chop work, which is why this example I thought was a great one, and it came from a member of the HQ Pro, and we helped them build this little tool, and we thought it would be a great thing to share. So there's a lot of shuffling, there's a lot of top to chop, some analyzing, and really it's just the combination of using these operators allows us to take something like, for example, this spinning rectangular block, and then based on the value inside of the alpha channel, essentially create a dynamic cropping system that'll crop right up until there is anything with alpha inside of that row or column of pixels. So let's dive into building this. So what I'm going to do here is delete everything, and we're going to start from scratch. The first thing I will do is make a rectangle top here, just as a little bit of example content for us. And what I'll do is I'll make this kind of a long, skinny, easy to rotate object. And what I'll do is I'll make a LFO chop to do our rotations, and I'll likely put a math chop after that, and then a null chop after that. And what I can do on my rectangle top is find the rotate parameter and drag and drop this channel as an expression. Now, right now we can see that it's going from a value of -1 to +1, which is not a lot of rotation, unfortunately, but that's why we have our math chop. So I'll go on the math chop's parameters to the range parameters, and I know my from range is -1 to 1, and I want my to range to maybe be from 0 to 360. And now we got this nice spinning rectangle, although it's a little bit too fast. So on my LFO chop, I'll turn down the frequency, just so that'll be easy for us to watch and see what's going on when we're testing our system. The next thing I'm going to do is quickly create just a little constant chop here. And that's just to hold my width and height information. So I'll name my first channel width and my second channel height. And what I'll do is click on the names of these parameters to get my expression drop down, and I'm going to grab the Python expression for the width and height directly from this top. So in my width, I'll say op rectangle 1 dot width. And then for my height, I will do the same thing. I will grab op rectangle 1 dot height. Perfect, so I've got my initial setup, and I guess the last thing we do need for our setup is a crop top. So I'll connect my rectangle to the crop top, and then these crop left, right, bottom, and top values are what we're going to control to dynamically cut in on every single side. The last thing I'll do actually on this crop top before we move into the chops is change the units that it's using by default. So a lot of parameters inside of TouchDesigner by default will use a fractional kind of value or unit, and that means that it's going to go from a normalized range of 0 to 1. So we can see as I go from 0 to 0.5, that crops the left half of the screen off, and if I go all the way to 1, that crops the whole thing out. And in this case, because we're actually going to be doing a lot of chop processing, we're going to know the exact pixel rows and columns where we want our cropping to happen. So I'm going to switch all of these over to the pixels mode. And now we're ready to dive into chops. And you don't have to be worried about how intimidating some of these techniques might feel, because especially if this is your first time, using something like a top to chop or using shuffle chops, it definitely feels strange. But the thing I always try and remind folks about this process is if you can visualize it, it becomes a lot easier. And you're going to see as we're going through this process, we're going to take quick little breaks in between some of the sections just to think about how we can visualize and make connections between the chop data we see and the top data that we have as well. So to get started here, I know that I'm going to be processing all of this inside of chops. What I'm going to do is create a top to chop. And a top to chop, what it does, it takes all of the information from inside of the pixels of data in a texture and gives it to us back as channel values. Now, this is somewhere before I even do this drag and drop. This is a warning for folks who are maybe on older machines or not super powerful machines. By default, it's going to try and grab RGB and A channels, and the crop at least is going to be set to row U. So that means it's going to grab the middle row of pixels and give us all of the RGBA channels. So it's really important that if your computer is not super strong, make sure whatever texture you're using here, if you're not using a rectangle, isn't too big, because it can get really slow really quickly. And that's why today, for our example, we're really going to be totally fine working with this 256 by 256 rectangle. For the purpose of what we're building, totally won't matter if it's 256 by 256 or 1920 by 1080, but the 256 by 256 will keep it nice and speedy while you're working and experimenting. So I'm going to go ahead now back on my top to chop. On the first page of parameters, I see the top reference here, so I'll grab my rectangle and I want to drop it on there. And again, like we talked about, we're going to do a lot of this kind of visual comparison, and I'm going to do a lot of pausing inside of the network so we can see. But what we see here, like I said, right now it's giving us the RGB and A channels and the values of all of those pixels in the middle row right across the middle of the top here. And what you can see is that when our rectangle is rotated to be long, we actually see a similar kind of shape appearing inside of that chop data. And if I unpause it and wait for our rectangle to kind of be more vertical than horizontal, we're also going to see that kind of represented inside of our chop data. And there's going to be a lot of ways that we're going to look at this, and trying to make those connections, I find for myself personally, really helps me work with chops a lot easier. Now, there's two things we have to do with this top to chop here. So I'll go ahead and unpause my timeline. First thing we have to do is get rid of all the extra data that we don't need, because the requirements that we kind of set out for this example is that it's going to do all of the cropping based on alpha channel. So if there is no data in the pixel in the alpha channel, we're essentially going to crop it out. But if there is any data, it's going to be considered a pixel in use. And because we're using the alpha channel, we don't even need the R, G, and B channel. They're just going to be extra data that's going to clutter our workspace. So what I can do in the top to chop is go to the parameters, delete the R, delete the G, delete the B, and all I'll be left with is my alpha channel. Now in this case, we have just a single row across the middle, but what we're actually doing is building a dynamic cropping on all four sides. And when you start to think about what we're actually doing from a kind of problem-solving perspective, essentially what we're going to do is scan through every row of pixels, scan through every column of pixels, until we find the first row or column that has alpha information in it. Once we find that row or column, we're going to know, oh, you know what, we can crop right up to there, because that's where our first bit of information starts as we're scanning left to right, or right to left, or top to bottom, or bottom to top. So this idea of scanning through, looking for the first piece of alpha information that we see in each of those directions, and then finding what pixel row or column that's going to be, that's kind of our main mission today. Now, because of that, we're going to need more than just the middle row of pixels. We're going to need all of the rows of pixels. So in my top to chop, I'm going to go to the crop. In my top to chop, yeah, top to chop. It tongue twister sometimes, you know. I'm going to go to the crop page of parameters, and in the crop parameters where it says row U, I'm going to switch this to full image. Now again, this is another one of those areas where if you're on a little bit of older hardware, or your CPU isn't kind of, you know, fully dedicated to the mission we're on, a lot of times doing something like this, switching a top to chop to the full image mode, especially if you have RGB and A activated, can end up being a lot of data. Because right now you can see we have 256 channels, and each channel has 256 samples. So that's, you know, that's quite a bit of information in here. And even again now, I'm going to do what we just talked about, which I'm going to make this viewer bigger. And I'm going to start to look through the data a little bit as I see the rectangle moving up there. And what we're going to see is the top of it is always empty, and we can see it has a value of 0 because there's nothing really in the top of our image here. And this is something I really suggest you do in your own practice, is try to make guesses about what you're going to see and see if your guess was correct or not. So for example, if I pause this timeline, maybe somewhere right here, my guess as to what I'm going to see is a lot of channels of 0, and then I'm actually going to physically be able to see that kind of peak of the rectangle in my data as each of the progressive rows of pixels gets more and more alpha information in them. So if I start and kind of scroll through my top to chop here, where if you remember, we're in full image mode, so that means that every channel is a row of pixels and every sample that we look through is a column of pixels. So as I scroll down, I see a lot of nothing. Oh, and then I start to see the tip, and then it goes down and it goes down and it starts to get wider and wider. And we can see, look at that, it looks exactly, so now it's a little bit opposite because you can see in our top to chop, it kind of goes from top right to bottom left as opposed from top left to bottom right. But that's a pretty easy thing for us to fix with something like a stretch chop, which we'll look at in a second. So in that sense, we're kind of making those connections between chop data and top data. I'm going to right click here and reset my node size, because I always say for programming, don't change the size of the nodes, but sometimes for viewers it's nice. So we already saw one complication that we have here. It's that our top to chop looks kind of flipped in comparison to our actual top. So what I'm going to do is put a stretch chop after this. And stretch chop has a really unique parameter in it that I use a lot, which is the reverse interval. And essentially all this really does is it takes the chop data that you have and just flips it around. So if I was to go scroll down a little bit here, and I can see that I have this chop data and it's kind of going from top right to bottom left. If I hit reverse interval, you can see now it's totally flipped over, and now it goes from that top left down towards the bottom right. And that orientation visually for us makes a lot more sense because that's kind of the same orientation that our rectangle is in inside of our top. Great, so now our next step is to start to think about our problem again. We're doing our scanning, so we've essentially got the scanning a little bit set up, but now we have to start checking for values. And anytime that I'm trying to grab a channel that has lots of samples in it and reduce it down to a single data point, even before I really know what I have to do, my mind almost immediately goes to analyze chop. And you might have used analyze chop before if you've done work with audio analysis or anything like that. It's a really great way to take a complex kind of series of data inside of a channel and compress it down into a single value. So what I'm going to do is make an analyze chop here and connect my stretch to it. Now, the great thing about this analyze chop is how many different functions it has inside of it. Now, if we click it, we can see all of these different kinds, and to be honest, there's more than one way you can do this problem, but because we set our requirement that basically any channel with alpha in it equals stop the crop there, we could probably even use something as simple as maximum. And what this is going to do is if there is no pixel value inside of that row of pixels, you're going to see we're going to get a value of 0. But the moment that there is even a little bit of alpha in that row, so like for example, if we go back to our full data set here, we can see the very tip of the rectangle is right here. So even that little tip of the rectangle putting some alpha information in that row of pixels, and we can see that's A69. If I go to my analyze and zoom in here, we can see that A69 has a value of 0.2706. So that's essentially our first row with data inside of it. Now that's great because this maximum inside of our analyze will do that all the way top to bottom. And again, this is one of those great places to just take a moment and kind of compare and see if the visuals that you're seeing kind of match the visuals of the chop. And I think for a lot of people that are doing this for the first time, they might say, oh, there's like no relation. But then you look at it and you say, you know what? There's a lot of channels of 0. Then there's a quick little on-ramp of a little bit of data. And then there's full alpha inside of here. So basically from the tip of this down to the bottom tip of this, there's going to be at least 1 pixel in every row with an alpha of 1. And remember, this is set to maximum, so that's why all of these channels are set to 1. And at the end, there's going to be a little point that probably has a little bit of alpha roll-off on the end of it. So this is actually doing a really great job even representing the state of the rectangle. And if I unpause this, we can see when the rectangle gets again into that more horizontal state, it compresses because there's more channels above and below that are showing us no data in them. Now this is great to know because we're going to have to do this same process twice. And what we're starting to see here is that we're doing this process for our bottom to top crops. So we're going to focus on the top and bottom cropping first. And then I'm going to show you a trick on how we can use that exact same process, but for our left and right side cropping. So already we're starting to see, you know what? I can kind of start to tell when I have values and where I have to crop to. But we still have a little bit of things that we can do here. The first thing I would add to this is a logic chop. And the reason for this is, you know, right now we're using really simple content. It's just a rectangle that's spinning around. But once you introduce a little bit more complex content, or it's a movie file, excuse me, you will not want to have, you know, too many different pixel values that are, you know, in between 0 and 1. You know, in this case, because our requirements were so strict that if there's any alpha value in that pixel row, it's considered an active row of pixels. We want to just remove fractional values from the equation. And that's why logic is great, because what logic will do is take what we already had, which was the maximum value of every pixel row, and essentially turn that into a binary value. So either we're going to have a 0 when a channel does not have information, or in this case, let me open up this viewer, it will probably be easier. So either we're going to have no data, or a very resounding 1 for yes, there is data somewhere inside of this row. And I find, especially when we're working with logic systems and building these kind of networks that are dynamic and doing calculations, having that very strong 0 to 1 binary aspect of it really helps make it a lot easier to deal with. So now we kind of have this set of data, which tells us, you know, which channels have data, which channels don't have data. But we have to turn this into some kind of pixel reference value that we can put inside of a, you know, crop from bottom or crop from top value of our crop top. Now this is where another amazing feature of shuffling comes in. And I say another because I'm thinking about shuffling all the time, but sometimes it's the first time I say it, I'm already thinking another. Now, when we use Analyze Chop, you know, one of its amazing benefits is, just like I was saying, it has the ability to take complex chop data, multiple samples in a channel, and kind of give us a single result back. Now, the tricky part with Analyze Chop is it can't do the same thing for this kind of data, for single sample multi-channel data. So if I wanted to just use a chop to extract from this logic chop, you know, hey, what's the first channel number that has a value, or what's the next what's the second area where data stops, it's not really going to be able to do that naturally and intuitively. But we can kind of cheat, because what we can do is create a shuffle chop after our logic, and we can use the method swap channels and samples to basically take that stack of data we had and essentially transpose it and rotate it. So we haven't changed any of the values, we're just changing its appearance and kind of presentation format. And you can see what we can do now is run this through another set of analyzes and start to pull out some more information. So what we could do, for example, is connect this new shuffle to our analyze. And there are a lot of really cool things we can do here. Now, if you've never used any of these first peak, last peak, highest peak, or lowest peak options, they're really cool, because what they'll do is they'll actually analyze the whole series of the channel information that you have here, and they'll actually give you specific either values or sample numbers where events are occurring inside of that data. And this is perfect for us, because what we said we wanted to do, if I pause this here, actually let me get it to right there, so we can see our data as well here. What we want to do is, now remember, even though we rotated our data so that it's all in one channel, it's still representing the top to bottom values of pixel rows. So it's always good to keep, as you start rotating and transposing data, remember what it actually is. So in this case, we want to know where this sample is, because that's going to be from the top to the bottom where the first value of pixel starts. And then we also want to know where this line right here is. So that's going to be the bottom of the image where the content basically ends and we go back into blank pixels. Now, if we want to get kind of the sample of this and the sample of that, Analyze has two great ways we can do that. So if I go to my Analyze, let's start with the first value here. What I'm going to do is switch this to the index of first peak. Now, when I set it to the index of first peak, by default, the way peaks are calculated is it's going to give me the sample over here. Now, that's fine because we're going to use that, but we'll come back to that because what I first want to grab is the sample value right here. And there's a very useful button on an Analyze shop that says Analyze Valleys versus Peaks. Now, right now you see all of these different options for detecting peaks. But when you turn this button on, what you can do is imagine that all of the options for peaks are now the options for valleys. And essentially you can think of a peak as a spike, a high spike in the number, and a valley as a kind of a low dip in the number. So when I turn this button on, what it's going to do is it's going to find the index of the first valley. Now in this case, when we look at our chop here, the index of the first valley is going to be that right angle right where the 0 value pixels encounter the first row of pixels with data in them. I know. Remember, if it's a tongue twister for a pro like me, you don't have to be ashamed if it's a tongue twister for anyone else out there. But using this very simple technique, we got index of first valley because we turned on this button. That's going to give us the sample right there. And if you remember, because of the way we've been working, that sample number is going to correspond to the channel number here. And the channel number, if we keep going back, is going to correspond to the pixel row number. So we're almost most of the way there in knowing exactly how far from the top to the top down we have to crop to exactly cut this image perfectly. So we've got this 61 here. I can even go ahead and put a null, and I know that's going to be 61 pixels from the top down. So I can even go ahead and try putting a nice expression in here. So if I go to my crop top, I can see that one of the things you're going to encounter is that the crop top starts pixel 0 at the bottom, and it counts up from 0 all the way to 256 at the top. Whereas kind of the way we're working is 0's at the top, and we're counting down pixels. Now there's a really easy way that you can get around this, which is that what we'll do is essentially take the height information that we put in our constant, and then what we're going to do is subtract this pixel value here, which is going to tell us how many pixels from the bottom of the screen we should crop in. I know it sounds confusing, but let's take a look here. So, for example, we have 61 pixels from the top that we have to crop in. Now, in this case, the crop top does a nice thing where when we changed it to pixel mode, it automatically set our 0 to 256 ranges. Now, if you were going to make the system dynamic, which is what we're going to do, you don't want to be locked into 256 by 256. You want to be able to take any kind of input, scale it, and deal with it accordingly. So that's why I can't just take 61 and put it in the top here, because that's going to be 61 pixels up from the bottom. Now, if I was going to do this manually, this would be 256, and I could say, you know what, 256 minus 61 is going to give me exactly that pixel where my last bit of alpha information is. And we're essentially just doing this same thing, but we're going to do it with some expressions because we want it to be dynamic. So instead of saying 256, what I can do is go to op constant 1, and I can get channel number 1. Or if you like, you can kind of replace that with the word height, so you have a very clear image of what that is. That way, if the resolution of our source ever changed, that expression would update itself. And then instead of putting 61 here, we're going to put a reference to that chop below. So we're going to say op null 2 channel 0. Now I'm going to make this a little bit bigger And you can pause here if you need to copy this. But now we've already gotten, I would say, 80% of the way there. And I'll explain why I say 80% of the way there. Because now what you can see is as I pause and unpause this timeline, we've already got this really cool effect where it kind of looks like the rectangle is spinning and kind of like rolling on an upside down floor, but that's just because our dynamic cropping is working correctly. Now, the reason I say we're 80% of the way there is because a good way to imagine a lot of these problems in TouchDesigner when you're working on them is if you figure it out once, usually you can copy and paste that solution and change some of the inputs to make it work for other elements of what you're working on. So for example, now that we've got this top to bottom cropping, cropping the bottom is going to be very easy because like we already saw, if I make another analyze chop here and connect my shuffle to it, what I can do is instead of doing index of first valley, I can switch this to index of first peak and leave this analyze values versus peak button off. And this is now going to tell me, so starting from the top, if I was to count down, 190 or 150 pixels, that's the row to stop on. And then very similarly, we can do the same math that we're doing for our top and say, you know what, the way we're going to calculate this is, again, take our height, subtract this new number that we have from it, and that's how much from the bottom we have to crop up. So I can say very similarly, grab this op constant 1 height, and then subtract op null 3 first channel there. And I'll make this a little bit bigger in case you want to pause and copy and paste that expression. Now, once you got that, you can already see, that's why I was saying we're almost 80% of the way there, because once you do it once, there's a quick way to get from the top to the bottom. So now we've got 2 dimensions doing automatic cropping. And the cool thing is, like, this is totally dynamic. So if all of a sudden, what can we do here to make this interesting? We can change the size of it, for example, make it longer. We can make it more square and see how that affects it. Whatever we want to feed into it, as long as it follows the same parameters and the references don't break, it's going to be working great. So now we've got top and bottom. Now, one of the really interesting things is how we can copy the top and bottom by using another shuffle to keep the exact same process. So if you remember this last time we talked about shuffle here, we were talking about transposing our data. So we had all of these channels that represented the pixel rows from top to bottom. And what we wanted to do is turn it into a single channel that was still representing the top to bottom rows of pixels. But what we can do is we can do the exact same thing back to our original data set. So what I mean by that is I can take a shuffle here, connect this stretch to my shuffle. And if you remember, the stretch is basically every single row of pixels. What I can do is, in a very similar method where we rotated this logic chops data, I can actually just rotate the full set of data that I have in my stretch chop here using that same swap channels and samples. So when I enable that on my original data set, instead of every channel here being a row of pixels, I've taken that kind of idea and transposed it 90 degrees. So now every channel is a column of pixels. And I know that's a tricky one to imagine. I always say the best way to think about it is this shuffle, channels, and sample swapping is really like a rotation, and imagining it like a rotation makes it a lot easier to kind of wrap your head around. But in the same way that we had, a bunch of channels and we rotated them into a single channel with multiple samples, what we're doing here is basically taking the full set of data where we have lots of rows, and we're taking the rows and just rotating the whole thing. So now that our channels across are actually the columns going up and down in the image. And the reason that's cool is because once we do that, technically the rest of our network doesn't know the difference between rows and columns. It's just doing number crunching. So we could take that exact same chunk of operators that we made, copy and paste them, plug this shuffle into them, and now we have the exact same data for the left side and the right side crop. And all we got to do is assign those to our crop top, and we've got a full 4-sided automatic dynamic super duper cropping tool. That's patent pending TM coming soon to a theater near you. So let's just finish up by assigning these values. So I can see that this is my left to right value here. So I'm going to grab that. And the nice thing is the left to right starts from 0 and goes to 256, both in the crop top and in our top to chop. So we don't have to worry about that. So I can just go ahead and grab this channel, reference it for my left side, and then grab the higher number and reference it for my right side. And lo and behold, we've got ourselves a great dynamic, automatic, alpha-based auto cropping tool. There's been a lot of mouthfuls in this video and a lot of tongue twisters, but I'm glad we made it there. And we could even try experimenting stuff like what happens if the edges aren't sharp. Doesn't matter, it still works because the system we've built is literally going through every single row and column of pixels looking for bits of alpha data. Now the cool part that I'll leave you thinking about this, and this is why you always hear a lot of pros talk about the importance of shuffling, working with chops. If you were going to make something like this in Python, I don't know if it would drop frames exactly, but it would probably be quite a heavy script to run every frame. But when we build this in chops, I mean, this is running at 60 FPS. I could definitely crank up the resolution of this and it would still run at 60 FPS, and it's just such an efficient network. The heaviest part of it by far is this top to chop, but then after that you can see most things are pretty cheap in terms of their processing power. You know, Analyze is very cheap, Logics are pretty cheap, and you know, we're using a lot of Analyze thankfully, so those are very cheap. Really it just becomes a case of getting that data into chops and then processing that, analyzing it, doing a little bit of manipulation so that we can make this really cool automatic cropping tool. So I hope you enjoy, and I hope you get inspired to dive into chops a little bit more. I know sometimes it can be hard, especially when it comes to visualizing what all those flying numbers mean. But the more you can kind of start to create visual references for yourself between your content and chop data, definitely makes that process easier. Enjoy. Hey guys, thanks for watching. If you're serious about taking your TouchDesigner and interactive skills to the next level, I highly recommend you check out the Interactive and Immersive HQ Pro. It's the only educational resource and community of its kind for TouchDesigner and interactive professionals. You can learn more by checking out the link in the description. And if you like this video, don't forget to hit that like button. And if you're new here, don't forget to hit subscribe and the little bell icon for more awesome free content.